All right. So we use symbols to represent people or organisms in a pedigree, and we use different symbols for males versus females. When we are making a pedigree, we use squares to represent males, and we use circular shapes to represent females. When we're drawing a pedigree, we're usually tracing some characteristic, some trait, some disease, and how it's been inherited through a family. And so to indicate if a person in that family has that trait, we shade in their symbol. So if they have the trait, we shade it in. So this would be a male that has whatever trait we're looking at, and that would be a female that has that trait. Then the way that we connect the shapes is what tells us about the relationship between the different people. Can I even take a guess? What do you think this represents? A line connecting people directly side to side. Luke?
They're married?
Yeah, they're married, or not technically, they don't have to be married, but they had children. They had offspring. Maybe we'll say mating. They might be married. They might not. Now this is like a different sort of connection. Up and over like that. Brandon, what do you think that means?
Like, they're like the daughter and my son.
Yeah, that these two people are siblings. Whose symbols would be up here? Yeah, the parents would be up there. And where would their children go? Somewhere down here. Everybody in one generation, we try to keep all in the same line. So let's look at an example of a simple one. So in this pedigree, we're going to be looking at the trait of colorblindness. And we'll talk more about what colorblindness is in a minute. So I have a description of a family. A man that's colorblind marries a woman that's not colorblind. They have 3 children, a boy and 2 girls. None of them are colorblind. Okay. So a man that's colorblind, raise your hand if you could tell me what symbol are we going to use. Ava?
A shaded square?
Yeah, shaded square. A man, he's shaded because he does have this characteristic. He marries a woman who is not colorblind. Deanna?
A not shaded circle?
Yeah, an unshaded circle. Since they're married and they're going to have children, we connect them directly side to side. I'm going to draw a line down in a spot for each of their children. They have 3. A boy and 2 girls. None of them are colorblind. So what is their son? What shape is he going to get? Angela? He gets a square, unshaded. And they have 2 girls. Neither of them are colorblind. Body? 2 unshaded circles. So here we have a family, 2 generations of a family. And we're looking at colorblindness. Has anyone been tested to see if you're colorblind? Have you ever been shown diagrams that look like this?
Yeah.
That you remember? Maybe at the eye doctor, maybe at your pediatrician. So, can you see a number here?
Yeah.
Yeah, probably you can. But some people cannot.
I can.
This is a test for colorblindness. And colorblindness, sometimes people have a mistaken idea about it. Most of the time, if a person is colorblind, it doesn't mean like they see the world in black and white. You know, that's what a lot of people think. There's different types of colorblindness, and the most common one is red-green colorblindness, in which a person cannot distinguish between red and green very well. For example, this is what the colors of the rainbow look like if a person were to have red-green colorblindness. Obviously much different. If you look at some colored pencils here. In normal vision, you can see the range of colors. Person with red-green colorblindness, you can see in the red shades here and in the green shades down here, they all kind of look similar to each other. And so they can't distinguish very well from those shades. I know people, a person that's a soccer referee actually has red-green color blindness, and depending on the uniforms that the teams are wearing, sometimes it's hard for him to distinguish one team from another based on the colors. So, it's fairly common. Especially, do you know who's most affected by this type of color blindness? No, you're sort of born with it, actually. Mostly men. Color blindness is actually what's called a sex-linked trait. Usually, sex-linked traits are more common in men. And what it means is that the genes for this type of color blindness are actually carried on the X chromosome. They're carried on the sex chromosome. And so, for a man to be colorblind, if they get one recessive gene for color blindness on their X chromosome, then they have color blindness. What about for a woman, though? Women can also get color blindness. But how many X chromosomes does a woman have? What are the sex chromosomes of a woman? XX. She has 2 X chromosomes. So if she gets one of these recessive genes, there's also a chance her other X chromosome might have the dominant normal gene and she won't be colorblind, because colorblindness is recessive. So for a woman to be colorblind, she has to happen to get one from each parent, which is much less likely than getting one from one parent. So that's why it's more common in men. The tests for colorblindness are things like this. They show you a pattern of circles. You could probably see, what's this?
10.
What about
42. 6. 7.
Yeah, and it may seem, well, that's kind of silly. Of course you could see them. But if you are unable to distinguish between these shades of green and the shades of red, it just doesn't look like anything. You can't see the number there. So you go to the eye doctor, they probably show you a couple of these diagrams. If you could pick out the number, it means you don't have this color blindness. And there's different types of tests for different types of color blindness. How about that?
15. 45. 6. 8.
Yeah.
73. 7. 26. I don't know. I'm colorblind.
No, so this doesn't have a number there, but this is, so if you were colorblind, that's what these would look like. They just look like a bunch of circles that are basically the similar shade, and you wouldn't see any number there. All right, let's look at another example of a pedigree diagram. Couple has 4 children, their mother has a widow's peak, the father does not. 2 female children end up with the widow's peak, and 2 don't. One's a boy, one's a girl. We're shading in widow's peak. All right, let's do this one together, then I'll let you do a couple on your own. So, couple has 4 children. The mother has a widow's peak. Let's start with the mother then. What symbol should we give her, Karen? Shaded circle. She's a woman, so it's a circle. She has this trait, this widow's peak, so we shaded it. The father does not. What symbol are we going to use for the father in this situation? Sam?
Unshaded square.
An unshaded square. All right, they have how many children? 4 children. So you need to draw a line down and then a spot for each child. Do you have a question, Karen? No, not necessarily. Sometimes they're in the other way. All right, we have 2 female children with a widow's peak. What symbols are we going to give them? Krista? Shaded circles. Then they have 2 that don't, a boy and a girl. What are their symbols going to be? Unshaded square, unshaded circle. So again, we just have 2 generations of people. Now I'm going to ask you for something a little bit more. So based on everything we know, and I'll tell you this, widow's peak is dominant. Can we fill in their, do we know their genotype when we look at this family? So some of the people, it's easy to tell their genotype. Which ones are easy to tell? Brandon?
The fathers and the son and the one of these 3 daughters.
Why?
Because they don't have it.
So they don't have it, so that means what must their genotype be? If they have the recessive phenotype, what's their genotype be? Yeah, 2 lowercase w's, right? That's the only possibility that's going to result in not having the widow's peak. So that's little w. We know this one, they don't have it, so they must be little w, and that person. But as we've talked about, when you have the dominant trait, it's a little bit more challenging to figure it out. So if you have the dominant trait, we know at least one of your letters. What is it? Capital W. Now the other one could be an uppercase W, or it could be a lowercase w. How could we tell which one? What do we have to know about to figure out exactly which one it is? Jenna?
What genotypes both parents have?
Yeah, we need to know either about the parents or we need to know about the children. So let's look at this. So they have a widow's peak. So we know they must have what? At least one what? One big W. Okay. So what about this person? So we know they have a big W. Why do we know they have a little w as well? Rihanna?
Because if you didn't have a little w, then the other two would have the widow's peak.
Yeah, so we have to think about, okay, where did these children get their genes? Well, these 2 children have 2 little w's. One of them came from who? One definitely came from the dad, so where must the other one have come from? Must have come from the mom, so she must have a little w in there. All right, do we know these 2? So what did these 2 get from their dad? That's all he has to give them. So they must have a little w, so what must they have got from their mom? The big W. So we can figure it out, if we know about the parents or the children, we can figure it out oftentimes. Not always, but often we can. So you think you understand how to make a pedigree? Pretty simple? All right, go ahead and do these 2 on your own. And then we'll skip the next slide if I feel that we're comfortable with this. You can if you want to. I wasn't going to ask you to, but if you feel that this is pretty easy, then definitely go for it. It'd be good, because you are going to have to on your homework. like we're pretty good here. So the first one, a tongue-rolling man marries a woman who cannot roll her tongue. Shade in the rollers. 2 daughters, both can. So man that can roll his tongue, married to a woman who cannot. With 2 daughters, they both can. John?
I don't really understand how that would work.
How that would happen?
Yeah.
So again, for tongue rolling,
Oh, no, wait, never mind, I get it.
okay, tongue rolling is dominant. Okay, so what's her genotype?
Probably WW.
Well, we'll use R's. What's her genotype? 2 little R's. Okay. Do we know their genotype? Brandon?
They got a little R.
They got a big R from their father. They must get a little R from their mother because that's all she has. Now, we don't know him for sure. All right. Mom with unattached earlobes. There's a child with dad with attached. 3 children. Their boys have attached. Their daughter does not. Got it? Too easy?
Yeah.
All right, we'll skip this slide then. If you feel confused at all, you can do this and I'll check it for you, but if you got it, it seems like everyone does, we'll skip to this. All right, now we got a challenge.
Sure did.
Now, let me give you one tip.
Joe.
So do not put Joe at the top of your pedigree. Because later on in the story, or not whatever, this paragraph, it's going to tell you about his parents and his grandparents. So if you put him way at the top, you're going to have no place to put the parents and grandparents. So start with Joe about in the middle. And then build your pedigree up from there. Okay? So go ahead and take a few minutes and do this, and then I'll show you the answer in a minute. If you could do this one, you're no problem. You're in good shape once we get to our quiz on track. Yep. If you do finish, let me look at it, and then I will give you your homework. Should be a little gap for his wife. Or put Joe at the end. So you have room for his wife. $2, and then the also have a son. And
Okay, I'm done.
this Yes. Good. No. Homozygous recessive. No. Homozygous means two of the same. Recessive. Hold on, I'm coming around.
So 2 little left.
Yes.
I know.
I'm working my way over the rows. Okay. Why is he waiting?
How?
Because I guessed something and I couldn't finish.
I had to run like
All right, how many goes? All right, let's just do this. All right. So if you're not done yet and you don't want to spoil it, don't look. But here, you can check your own. Joe, his father. There's his mother. His sister, or his brothers. And we have his other children. And we have his father's father and mother. And he gets married. And these are brothers and sisters.
Oh, that's a good idea to put on.
If you put Joe at the end, you have space for his wife. You could put him in here. You just need to leave a little gap there to put it in.
That was a good idea.
Now again, the order is not that important for our purposes. But check yours, make sure you know how to do it.
Is it okay if I like wear it?
Yeah, that's fine. Yep. And I'll give you your homework.
Hey.
Go check it out there. Yeah, you can work on your homework for the next.
Oh, yes.
This is so confusing. What am I supposed to?
This is great.
Is it homework today? A homework grade, right?
Hey.
This is so confusing.
It's just like any other pedigree.
No, it's not.
Why? Because it's Star Wars?
No.
You have to write their names.
Yeah, write their names, and you can figure out their genotype. I think there is one person who you can't figure out their genotype. Yeah, this is homework. You got 5 minutes. You should be able to finish, especially if you know your Star Wars.
I don't.
I've never.
I don't at all.
I don't know anything.
Well, then you've led sad lives.